Okay, so now that we've made acetals, imines, and enamines, we're going to talk about how to unmake them. All right, and remarkably, or maybe not surprisingly, it's going to be through the same way that we made them. Okay, so we're going to use water to break bonds, water, hydrolysis, cutting. We're going to use water to take this back to where we began, right? And so it turns out that in order to go from here to here, remember this? We got rid of water and we did it with acid. Okay, a bunch of proton transfers. Now we can add water, which we show here, of course, and do this with acid catalysis, and it gets the same thing. So I'm going to encourage you when you do this to do the same thing you did when you were making acetals, imines, and enamines, and that is keep in mind where you're going, right? Where you are and where you're going. So if I'm starting out with this and I'm going to this, then I've got to break a bunch of ROs off, right? And I've got to increase an oxygen, which we remember from making acetals and imines and enamines, that the oxygen that comes off goes off as water, right? That was that oxygen that came off. So I'm hoping you'll memorize this. Memorize not the mechanism, but the structures and the reaction conditions, and then just constantly in all your mechanism steps be thinking, how can I make more of the bonds that I need and get rid of the bonds that I don't need. Okay, so let's look at this mechanism. So suppose you have an acetal. Remember now, we've got to get rid of this guy, right? So the way to get rid of it is to make it a good leaving group. And a good leaving group is an alcohol, right? So the first thing that happens is we protonate, okay? Proton transfer. First thing that happens is we make it a good leaving group. Then it becomes an alcohol. Well, it's ready to go. And the only thing we need for it to go is we've got a lone pair of electrons right here, which can kick it off. Do you see that? Lone pair of electrons come down and makes a double bond. That's what the lone pair did. This lone pair comes down, makes this double bond, okay? And this guy kicks off as an alcohol, right? Beware, folks, by the way, that if this is neutral, before it takes on a proton, it's going to have a plus charge afterwards, a formal charge of +1. Those formal charges are really going to be very helpful to you as you try to keep track of everything. Okay, so the alcohol goes off, and then this lone pair which came down is now part of a pi system. All right, now a water molecule can come in. It's exactly the opposite of what we saw when we were making the acetal. Because the water molecule was leaving, remember that? Well, here the water molecule comes back in, and there's your water molecule that came in, right? And you know you want that water molecule on there because you got to get rid of this guy, right? So let's deprotonate that with another water molecule and make it stable. Okay, there's a hemiacetal, right? And you know what's going to happen next? We got to get rid of this guy. So in order to get rid of it, we make it a good leaving group. What's the good leaving group? Well, it's an alcohol, right? So this lone pair of electrons comes down, gets a proton from an acid, from a hydronium ion, which is close by. I mean, close by when it gets it, right? Becomes an alcohol molecule. These guys come down. Look at this step right here. Looks just like this step up here. Step 1 looks like that one. Can you see that? The lone pair of electrons comes in and kicks off this alcohol. Same thing happened up here. And then we get that lone pair of electrons, which now becomes the pi bond, and it looks almost complete. Look at that. Just deprotonated, and we've got our back to our ketone. All right. So again, I'm going to argue that you should memorize from here to here. You know you got to get rid of these. The way to get rid of them is make them good water molecules. I'm sorry, good leaving groups. The way to make them good leaving groups is to protonate them. All right. Okay. Hopefully that's helpful. Now, how are we gonna? Oh, let me go back to the previous slide. How can equilibrium be controlled? To give either acetal formation, which we have in section 20.5 or 20.6, either acetal formation or the opposite, which is hydrolysis. How can we do that? Well, there we go. Right? If we get rid of the alcohols, there's another loss of an alcohol. Right? If we're somehow getting rid of those alcohols, then we're going to tend toward the ketone. If we have a lot of alcohol, we're going to tend toward the alcohol. Toward the acetal. Man. Let me say that again. If we have a lot of alcohol, we're going to tend toward the acetal. It's going to be going this direction. Let me see it. Where's my marker here? Where's my marker? If we have a lot of alcohols, we're going to have a tendency to go in that direction toward the acetal. If we have a lot of water, we're going to have a tendency to go in this direction toward the ketone. Okay? So the imines and enamines undergo very similar mechanisms. I don't have those mechanisms here in this video. You should do them out. You should do the mechanisms out for the hydrolysis of imines, which are here, and enamines, which are here, right? Remember that? Amine? That's an enamine right there. And remember now, what you're going to be doing is you're going to be making this a good leaving group, right? And you're going to be doing that by adding protons, and then you're going to have water come in, and this oxygen comes from the water. Okay? All right. Hope that's helpful. Go do those mechanisms. And I think that one last point here, hydrolysis is not effective when a base is used, and I think you could do you could draw out the mechanism and prove to yourself why that's true. All right, good luck.